Hi, Chuck Winters here with ABC News at Allstate University with Maria Gonzalez.
Hi, Chuck.
I hear there's been some contemplation about redoing the killer casserole.
Well, yes, we've been trying to come up with a way to minimize costs. So in order to do that, we've kind of been altering the recipe, but it hasn't really worked out to our advantage. So we're looking to find a better way. So we're thinking of using an optimization problem to help us solve the problem of minimizing the cost of our killer casserole.
An optimization problem. How does one set that up?
Well, first of all, we have to figure out what our objective is.
Yes, sir. We were just discussing the issue with the killer casserole.
Why you say killer? What is this killer that you speak of?
Sergio, we need to save money. In order for you to make your chocolate cake, we have to try to find ways to minimize the cost of the casserole. So we've decided to employ some of our students to help us out with their knowledge of linear programming and optimization in order to find an optimal solution.
And how do you go about solving a problem like that?
Well, the first thing we need to figure out is what is our objective. Our objective is to minimize the cost of the casserole. However, there are some other constraints that we have to be aware of, like the nutritional constraints, which we have some specific protein, iron, and vitamin C that has to be in the casserole. And there's also a demand requirement. We have to be able to make 22 pounds of this casserole. However, Sergio has something else he wants to add to the recipe.
Would you like to know my secret to my masterpiece?
Specific ratio, you
It's a
said?
specific ratio, 6 to 5, potatoes and green beans. Okay.
Sergio, we're going to try that ratio 6 to 5 just for you. We'll see if that's an optimal solution to our problem.
Optimal solution. So what about costs?
Chuck, that is a great question. Let me figure that out. Oh, I just remembered. Potatoes, they're 40 cents a pound, and green beans, they're $1 a pound.
Well, let me summarize the problem and see if we can come with up with an optimal solution.
Optimal solution. Optimal is taste. 6 to 5.
Optimal solution is cutting costs while meeting nutritional requirements.
So let me get this right. Your objective function is to minimize cost. I mean, we know you can get potatoes for 40 cents a pound, green beans for $1 a pound, and you're also constrained by 3 other things. You have to meet nutritional requirements, you have to make at least 22 pounds, and I think Sergio said something about taste.
The ratio. The
The
ratio.
ratio.
6 to 5.
The cost. We only care about the cost.
All right, well, let me just pull out my handy-dandy solver and see what I can do.
Yes.
Okay.
Is this correct?
Yes.
Ho ho!
All right, it seems like we can come to an optimal solution. Let me just pull out my handy-dandy solver.
What are the results?
I would like to know.
Well, it appears the optimal solution to your conundrum is that you're going to need to purchase 10.14 pounds of potatoes, 12.16 pounds of green beans in order to meet your objective for minimizing the cost. I mean, the cost of the casserole with the given constraints would be $16.22. And
Wow,
it seems
that's
like you
really
can make-
cheap.
It seems like you can make 22.3 pounds of casserole at a time. Costs you about 72 cents a pound. for a
Oh,
unit size.
Sergio, we did it! We did it!
What about the taste?
Oh, I didn't think about that. What about if the nutrition changes? I wonder if we can make it even cheaper. What if?